for you out there. In any case, today, as I mentioned, we've got some demos prepared for you on command line tools and techniques, and these are things to help you with, research specific processes, like when you're collecting data, how to get data on and off of the cluster, and how to process data, filter it. Your project staging, how to ensure that you've got a consistent directory structure for your logging and where you're keeping your data, your results, how you timestamp it, how you keep track of all the different things that you need to keep track of. When was this job run? What parameters was it run with? And ways to do that sort of in an automated fashion, so that you can ensure that as you do different projects or work through, that you're keeping a consistent way of doing things you're familiar with. And then of course the experimentation component and how to best monitor and optimize your workloads. There's a lot to cover here. We're certainly not going to be able to get in depth into all these things. I'm really just going to scrape the tip of the iceberg, but hopefully we'll be able to keep this going and expand on it. But today, you got the HPC admin's greatest hits, and that is take this job and monitor it. That's Keenan Terry featuring Slurm. We got Lonesome Threaded Blues. Tom Hanlon's going to perform with HTOP, and then these files are made for Hawking, which I'll present here shortly. But just know that the goal of what we're going to try to present here today is to reduce the repetitive processes, make it really easy for you. If you think about having to, starting from a research project through the experimentation all the way to the end, all of the different things that are just kind of can be quite repetitive, or that you may not quite remember the syntax, or where was it I was keeping that file. So there's some certain things you can do to help automate and standardize, as well as your experimentation and optimization. So with that, I think we're just about ready to do the demo. So give me 1 second to get my screen share going, get my command line up, and I'll be right back. Stop. All right. So here you can see, hopefully you can see my screen. Was my console up or no?
Yes.
Okay, great. All right, so I've just got a folder I've created here, and much like you would if you were starting a research project, you might create a subdirectory in your Easily home to hold the project specific data and whatnot. And one of the things that we thought about demoing today was automating that creation process and keeping, sort of a handful of canned scripts that help you do that. But we thought it was more important really to kind of get into the meat of it. So the thing I'm going to focus on today is starting at your project. You obviously got to collect some data and get it onto the cluster. Now, use cases for that are, you may already have some existing data that you've used your primary data from a previous project, and you want to just copy it from your local workstation or a departmental file share, or wherever it is. And those you would use transfer utilities. But a lot of times you can get your sources from a public database online, and those oftentimes will provide an API, or will just publish the data in a straight HTML or HTTP GET format. And so that's the kind of use case when they just get some sample data on the cluster. But the tools that are more important for that kind of operation are your wget, and that's a wget. You pass it a URL with no other options. If there's no authentication protecting it or no API keys or anything necessary, it's pretty straightforward. Same thing with curl, which is another utility that you can use. This stands for capture URL. You can see there are a lot of different options because there are a lot of different ways that content is published online that requires different specifics. But in its most essential form, it's just a curl and the URL, as well as things like your git clone version control if you needed to include certain source code or build source codes on your project. So let's just take a look at the curl. Now there's a database I found out there, which is the consumer complaint database. It's quite interesting. And let's see here. If you take a look, they publish that data pretty much free of any authentication. It's pretty unfettered. And so you can, this is an example, but in this case, you could use curl to grab it. And so before I really get into that, just a couple of things that are useful that I'm going to be using in this demo. And that is, you can see where it says date stamp and timestamp with those sort of strange looking ones. What I've done, or what I plan to do, is to assign, as you're working through your project, you want to make sure that when you're logging things, when you did it and what it was. And in this case, if you're going to be doing something like we're going through and downloading or collecting data from a certain data source, you don't want to just necessarily, sometimes you don't want to just overwrite that data. And so you, instead of using the same file name over and over again, there's a way to sort of make them unique, and a date's a good way to do that, as well as for other reasons when you're doing logging, the date command's good. So there's a quick, if you do like a man date, you can obviously find there's a lot of information there, but you look for format, it'll show you the formatting options. The other thing I found is there's a nice feature of the man command, which you do this -K. This will show you the sections. And then we'll get into this later, but if I'm just going to do this just to demonstrate, you can search for a certain keyword using that grep command, which we'll talk about in a little more detail. But you can see there's a formatting section here, date format. And then if you really wanted to, make it handy, I can't remember what the date formatting syntax is. You could keep this in the sort of bag of tricks. And this brings up just the formatting information. You can see there's this, okay, here's these percent sort of escape code type things. And I'll just show you a quick way to use that. You can do something like date. Or we'll say date, and it's strange, but it's a plus single quote, and then you use one of those escape codes. In this case, we're going to do month, day, and year, and that should spit back our format. Then you can change it around a little bit if you like to do things like this. And you do all sorts of flexible formatting, but for the most part there. And then another important thing to know is you can always use that output and save it into a variable. And so let's just call this our date stamp, just like we saw in the example above. I'm going to say equals, and this is how you do a subshell. So that in case you don't know, you can do $ parentheses, open parentheses, and then whatever command you want to run. If that command is successful, or if it generates output, it's going to store it inside that variable name, and you can reference it later. So let's take a look and just do what we did there. MDY. All right, and let's see. Oops, I'm missing a paren. All right, now if I do the echo statement and see what's inside that variable, and a new construct for Bash or a newer one, you can just do this. But what I find in scripting when you're writing scripts is it really helps to kind of separate out your variables from the normal strings that you're using. And so you'll see that used in some of our scripts and things that we publish online. But you can see that's stored now inside the date stamp variable. And then let's just do something similar with the time. Call this timestamp, and then we're going to do, just because I know these, I don't have to refer to the manual, but you could refer to the manual to get them. We're going to do hour, month, or hour, minute, and second. Those are all capital letters. I believe that should work. So this should save the timestamp. Let's echo timestamp. And it's given us some semblance of a time identifier there. So I'm not going to get too nitpicky about it. But now that we have those set, we can kind of run our curl command. I'm going to get back to my grep statement. Let's see, there we go. Ask grep. HTTP sources. And what you see that these are just comments where I've kind of saved the format of the string. But the way it takes the string, this particular data source, the API allows you to specify a format. In this case, I'm going to get a CSV file because it's an easy way to demo some of the string processing stuff. And you can get minimum and maximum date, so you can limit the date range. Now, I will say this particular API, I might be missing something here because it's gathering a lot more data than I would expect. But let's give this a shot. Here we are with our curl command, as I mentioned. What I'm telling it is curl, save the output in this location, which is data raw complaints. I'm using my date stamp and timestamp that I set so that it's going to be unique and I won't overwrite it. And then I'm going to refer to this URL with the parameters that I want, the format, and then the range, date range. So let's see if that works. And you can see it's starting to download data. And so far, I've got a good chunk of it, 43 megs. Now, what that indicates to me is either there are a lot of complaints, a lot of data in the last, when did I start? From January to, well, let's see, I mean, from January 1st to January 1st, you'd expect a very limited data set there, but it keeps going. So I'm probably using the API incorrectly. I'm going to see if I can escape out of this. And I can't, so I'm going to do a kill all curl. That should take care of that. Kill all curl. There we go. All right, so in any case, that's just to quickly demonstrate how you use the API. And if you get your parameters right, theoretically, it should work. You should get a data set within the confines of your constraints. But let's take a look. We saved it here. at this location. So I'll look inside data, and we saved it in that raw directory. And we can see, let's take a look at what we got. We got a really large file here from the 6th, and then we got a couple from today that are fairly close together. And so we're going to take a look at our latest one, but we don't know a whole lot about it. Well, first of all, let's see just how many lines are in that command. And so one useful way to do that is this WC command, WC-L, and that's for a line count. It also provides a character count and different types of measurements for file nuances. But if we give it a name, data raw, and we're going to look at that last file, that's 40710. It says that we've got 555,424 lines in that file. So that tells us a little bit about how many lines we got, but what does the format look like? And rather than dumping that whole file to the screen, we might just want to get a sample, see, okay, what's our record layout look like, and does it look valid? Can we deal with it? And so a quick way to do that are the head and tail commands. All right, so we'll start with the tail command, and I'm just going to get, I don't know, 10 lines off the bottom of that file. So to do that, you'd say tail-10. That's going to give you the last 10 lines in the file. We'll look at the one for this. It's a unique. All right, so you can see there's a lot of text dumped out of that file. And it appears to be, we requested a CSV file. It appears to be that, because what that means is a comma-separated value file. That's called a delimited file, and that's a common way, an easy way to store data sets, because it really just, it's lines, or it's rows and columns of data, or if you wanted to get, I guess, scientific about it, it's a multi-dimensional array or a matrix. But it allows you to reference fields and records in field, excuse me. So the way that's kind of dealt with in Bash is that you can do certain types of string operations that will parse just blobs of characters based on what you provide as a pattern. And a really easy, quick way to do that is, let's say we're going to take those last 10 lines, and I want to see exactly, it looks kind of messy, what is actually in column 1. All right, so I'm going to say cut, and we know that our delimiter in this case, and keep in mind, it can be tab delimited, pipe delimited, semicolon delimited, whatever kind of delimiter, but the general term is called a CSV, or comma delimited file. It's really just a delimited file. But I'm going to say the delimiter is a comma. All right, so cut -D, the delimiter, and I'm going to want to get field 1. So this is a really short, easy, quick way to see what is in column 1 of that file. And we can see that most of them have a date, but some of them don't. And that indicates to me that either my cut command is not working properly, or the date is not really normalized, or I think what's more likely happening is that in this case, you can see that some of these fields contain really long, prose about people's complaints from, the borough or whatever. And that maybe causes problems, because there could be commas or many kind of characters in there, and the command I just ran doesn't really know. I didn't tell it anything about, well, no, just ignore everything in quotes and whatnot. So there's certain things you can do, like regular expressions to deal with that. Or in this case, just a demo, let's filter out the stuff that doesn't start with a number. So this should work. And you can see powerful text processing things there that have really cleaned things up for me. And now I've gone from this confusing mess of characters into a much more, field 1 has this information, and I can refer to the API to see exactly what that date means, when the complaint was filed, so on and so forth. But just sort of take that in, and a lot of the syntax you see here might be very cryptic looking, and yes, it does take time to really get a mastery of it. You have to we still find ourselves as admins, after doing it for a long time, having to go back and look at Stack Overflow or look at the man pages to see, what was that, the way you run it with that syntax. But once you get a grasp of it, it's really, really powerful stuff. So an example there of cut and grep. Another useful tool that you'll see a lot of times if you're searching around for people asking them a question about data processing on Linux is awk. I'm just going to take these out here. And awk is actually a programming language in itself, but it can be used on the command line pretty conveniently. And in terms of cryptic looking syntax, awks is, it takes the lead, but it's another way to use something a little more powerful than cut. Cut is very limited in what it will do for delimiters, and it will take a single character. If you try to give it anything else, it's really not going to do you much good. But the way you do awk is you'd say, okay, awk, the field separator value, and you can do actually patterns for, so you can use regular expressions, but in this case, we're just going to keep it simple. And then you have a code block that will execute certain commands. They're awk language commands. The one you want most of the time for data processing is the print command. And so what that should do is the same thing, basically, essentially, that cut did, except this sets us up for some more powerful processing. And so in this case, rather than kind of just ignoring the lines that contain strings, perhaps we could add a little more of a complicated regular expression. And I will include some links to regex, very powerful stuff for data processing and filtering. But you can spend hours trying to get the right regex stuff. So we don't have time to go into it today. In any case, just know that regular expressions with this sort of handful of commands, as well as others, very good for data processing. Let me just mention also, let's take another tail of that file. And there's a command called tr. And it's also I forget what it's abbreviation for, but it will allow you to deal with things at the character level. And it does things like it'll compress. If you have white space in the file, for example, you can use like a -s to make sure that, in this case, summarize or compress any white space. So if you have more than one space in between a word, it should remove it. The other thing you can do, you can delete characters completely. So we can delete all the spaces, and you can see there, it's removed all the spaces. We can do that. I think we can do 2 characters here. Maybe not. Yeah, we can delete spaces and commas. We can do spaces, commas, parentheses. And you can see kind of the power of cleaning up. Let's get rid of the double quotes. So interesting stuff there. Another thing is for sampling. Let's say that you've got a very large data set and you don't want to necessarily just dump the first part of it. Maybe there are, dissimilarities between the first part, middle part, and end part of the file that you want to capture in your processing. This is a helpful command called shuffle, that it's actually just shuff. And what it'll do is it'll give you a certain number of, let's get 20 random lines out of that file. All right, and so after it had to parse all 500,000 lines, it came up with what I'm pretty confident is 20 random lines from the file that I can then dump into a sample file, for example. So we've got a very large data set. We want to actually just sample it. We'll run this shuff command, and then what we can do is redirect to a different directory. So let's look at in the data directory. We've got that raw data, and we've got this one called filtered. So let's take our sample and put that actually in filtered data. And we'll call it complaints. Random. And what we should end up there is now a much smaller file that has random lines from it there that have been sampled, and we can run some experimentation or testing on it. And so I don't want to take up too much time because I know the other guys have got things to do. Just know that there are, and this is just the very tip of what you can do with text processing. And if we have some more time, or we have specific questions at the end, or we want to do some sort of live, hey man, try this and see what happens, we can do that. But I think I've talked for a good while, and I've shown some of the things I wanted to really point out. The main thing being, if you can learn how to do this during your experimentation, let's say you're running experiments, you got a bunch of experimental runs going on, and you're not really certain yet whether or not your results are quite operating like you'd like them to, or especially on the data collection and result phases of your experimentation. You can use these commands. They're available everywhere. They're readily available. You don't have to load modules. You don't have to install anything. They're pretty ubiquitous. You go what other clusters are going to have them. These things will allow you to really more actively monitor your experimentation output and input, because you can use them as a experiment's running and as a job's running to do certain things like pull out a single number from a column and average it, things like that. In addition, it really reduces the headache of having to repeat data download operations, data movement operations, file copy files. So that's really kind of what I think this portion of the talk today discusses. But if it's okay with Keenan, if he's ready to go, I think I'll hand it over to him to do a little bit about monitoring jobs from the Slurm perspective. Take it away, Keenan.
All right. Can everyone see my screen?
I can, yes.
Can you? All right. Yeah. So we're going to just talk about how to monitor jobs. So Bradley was talking about very general things that you can apply to any Linux command line environment. This is going to be real specific just to the Easily scheduler, which is Slurm. But how do we monitor jobs? And there are a variety of ways to do that. You can use the SQ command, and I've teed up a couple of jobs that we can look at. So we see here there are jobs. There are the job numbers. One is running. That's the R. One is pending. So it gives you some basic information. You could also do it from just pulling one of those jobs. So use the -J option. Again, some pretty basic information on it, but it's good. Tells you the partition, again, the state of the job, how long it's been running. This one hasn't been running because it's pending. So good basic information. Another one you can use is S-Control. S-Control show job, and we'll look at the running one. And this gives you a lot more information. It's kind of busy. You have to kind of poke around. And even though I've looked at this for years, I still have to kind of stop and go line by line. But it shows the state of the job, which is pending. And let's see. It says a submit time. So I've submitted it then. And there's a start time, the partition, the node it's running on, the resources allocated to it. Actually, this is so a lot of good information. But the thing about the SQ command and also the S-Control show job is it gives you information on pending and running jobs only, but not completed jobs. So those commands are going to the scheduler and what it has in memory, and it can bring that down. But once it's completed, it's going to get out of memory. But Slurm also has a way that you can get historical information on jobs, and that's using S-Account. So let's try that. Tell you what, I'm going to go back. And I'm going to just point this out real quick. If you noticed when I started, 593376 was running, and the 378 was pending. But now you see the 376 is pending and the 378 is running. That's because it was preempted, and I'll kind of circle back around to that. But just let's use the S-Account -J. Again, you can put a specific job, and it's going to give you basic job information on that. Again, it's running, shows the account that it was running under, the partition, that kind of thing. But this account has a lot of power, again, because you can get historical information. So you want to look at information on jobs or the resource usage of a job from the past, pretty much from the history of the cluster. You can go back and pull that. You may be that you've forgotten about certain jobs. You don't know how you submitted those. You don't know the job submission line you used. You can get that. You don't know the batch job that you used. You can get that. Or the batch script, you can get that as well. So let me illustrate that. And again, if you take nothing away from this whole thing, probably just using man pages. You saw Bradley use them. I'll use it here. This is just kind of an exhaustive information on any command, and just a good place to go. So I'm going to use just a handful. And if you go in here and kind of dig through it, you'll find some stuff that probably a lot cooler than what I'm doing, but it's very helpful. And so you can see all the different options that you can use. But one of the best things about S-Account is you got all these different fields that are available and that you can include in your S account. So let's use a couple of those to get more specific information. All right, so we'll pull up. So here we have more information on it. Again, some of the same information, but just to illustrate these different fields that we saw before. The actual node that's running on, number of cores. Again, there's the state, there's the start time, there's the wall time that was used. It's been running for 4 minutes, 16 seconds. So just good information. Again, you can go back to those fields and get a lot of other information in addition to this. Let's say I wanted to go back to a specific point in time. So this shows all the jobs that I've ran in the last 24 hours. So if you see the command, you can see, again, we're using that format option. We're getting some information, but we're saying start time, 24 hours ago, up to the end time, which is 0 hours ago. So up to the present, give me all the jobs, give me this job information. So you can see I've had a number of jobs. So yesterday I submitted some jobs. That was the 6th, some of those completed. One of those, actually this is today, the 7th, one of those timed out, canceled. There are some running, there's another one pending. So really good way to get information. You can go back pretty much as far as you want to go. You know, you can say 24 hours, you can say 168 hours, which would be a week. I think you can change that date format like Bradley illustrated, because that's the same date command that he used. So if you want to do it by another, I think you can do it by probably weeks or something like that to get in a friendlier way to use it. But another thing, I just saw I pointed out that the job was preempted. And that's a common question I would get. People will say, hey, my job was running. It's been restarted multiple times. What's going on with that? Well, typically your job's been preempted. And the way to find that on your own, let me get back to that. Again, using the S account. So there we see that job. So in this case, I'm using S account. Again, I'm using that formatting. And again, there's two different ways to do it. You can use that dash format or just a -O. It's exactly the same thing. And you just specify the field that you want. This %8 is just going to show you just going to specify the column width in characters. And that's going to be right justified. I think if you put a minus sign, it's going to be left justified, but this is going to be right justified. So on the job ID, I'm giving this 8 characters. On the user ID, I'm giving it 8. Partition, I'm giving it 12, and so on. But in this case, I'm specifying the state of PR, which is preempted. And if you go into that man pages of S account, you'll see all the different job states. I mean, there's pending PD, there's running R, there's failed FA, canceled CA, completed CD. There's a bunch of different states that you can specify. But this would be a way to say, okay, give me all my preempted jobs. And you can see, oh, okay, that's what's happening. I'm getting preempted. So lastly, let's see. I think the handiest things about the S account for me, and I'm doing just a lot of troubleshooting, but you can get that job submission line. So you just put in that -J. Well, first of all, you put in submit line, and I want it to be 140 characters, and it's this specific job. So there it is. That's what I use to submit the job. And also I can do the the batch script for the job. So it's giving me everything. It's giving me the script. It's giving me all my Slurm directives, but also, what I'm running, the actual kind of little program that I'm running there. So very useful information. Again, if you wanted to go back and say, oh, give me jobs from a year ago, and I can go in for a specific job and say, okay, this is exactly how I submitted that job. This is exactly the batch script I used, which is very helpful. I know, at least for me anyway. The last thing I'll cover is the fact that these jobs, they're cumbersome. If you had to type this out every time, that would be a pain to do. So there's a thing that Linux offers alias called an alias command. And you can create an alias for a long command like this just to make it simpler. So you can do that. You can go out to, and I'm using the VI editor. You'll probably want to use something else. And there's a file called .bash aliases. And you can just create an alias. So you do alias and name your command. I'm just going to call it pjob. I just want to find preempted jobs. And you do a single quote. And I'm just going to cut and paste that. I think I butchered that. Let me back out of that real quick. All right. So I've just put it in there and closed it within single quotes. And you'll want to source it, which a source command is just going to run that script, but it's going to run it in your current shells to make that available in your current shell. So maybe I'll just illustrate that. So I've got pjobs. That command's not found, but after I source it, again, I'm sourcing that file that I changed. And I'll do pjobs again. There it shows my preempted jobs. And so this is, if you get nothing else, this might be the best thing would be the fact that create aliases for your workloads and for your different things that you use on a repetitive basis. Even small things will save you a lot of time. And I think that's all I've got. Any questions on that? Did that make any sense at all?
It made great sense. Thanks. Yeah, good stuff there. I like that. A lot of the other commands use aliases command a lot. I don't. It's not something I've really used very much. But aliases are going to be very helpful for those long cryptic looking things. The thing we'll be aware of with aliases is that once you create them, sometimes you forget that you did, and so you can just run. I think the aliases command to show you.
Oh yeah,
right?
Just run alias.
Yeah,
if you want an alias on a specific,
if
you want to do it on a specific one.
It shows you the exact syntax.
See my screen up there? Yes, no.
Sorry, I can see it. I can see your screen.
Okay.
Got the MOBA Xterm, which is a handy tool if you're not aware of the MOBA Xterm. I want to take a look at it over Putty. But it seems to be taking Putty seems to be taking a back seat to these.
Yeah, I if you're a Windows person, MOBA Xterm is super useful. At least it is for me. It allows you to go ahead and you've got like SCP stuff directly on there. You have multiple sessions. If you have a lot of sessions, it really helps for keeping track of stuff. You can go ahead and record macros, and it's got various tools that are associated with it. But sort of nicer is just the tabbed interface, and being able to set up tunneling and multi-exec across various boxes. Anyways, that's not what I was here to talk about. So what I was going to do a quick run through of was HTOP, which is useful if you need to look at what's going on a machine, specifically with your job, if you're running something. So let's go ahead and just grab somebody. I'll go ahead and I'll say, let's look at these nodes, node 801. So SSH node 801 HTOP. So that's just if you have a job running on a bunch of nodes or on a specific node, you would go ahead and do an SQ, find your job, look at it, see what node it's on, and I want to look and see what sort of resources it's using or are being used on that box. You can do an SSH-T, which says go ahead and give me an interactive terminal locally so I don't actually have to log into it. The name of the box, which is node 801 and HTOP. If you do an SSH to any machine, you can actually just do SSH, whatever, ls temp. It'll just go ahead and give you whatever is in temp. It'll run that command on the remote machine and give you stuff back on your local machine. We're going to do it with HTOP. So if I look at HTOP on this local machine, I can see that this person is, they're soaking it. They've got, like, you can see up here on the top, you've got, these are your processors, you know, and this is obviously a 28 processor machine. So
Yeah,
I've
that is
got,
not the lonesome threaded blues for sure. They're taking full advantage there.
yeah, they're taking advantage of this. So at the top, you have your processors, and it's telling you how much it's being used on each core of the processor. If I was on a 48 core machine, it would show me 48 up there instead of 1 through 28. And underneath it shows my memory, and it shows my swap underneath that. The colors are, they kind of change because, you know, if you just hit H, it'll give you a help screen. It'll tell you this is what it currently is with this current color scheme. It's saying my CPU usage, if it's blue on that bar, it's low priority, green is normal priority, red is kernel, the light blue is virtual. On the memory bar, it's used, buffers, and cache. So you can go back and you can look at that and go, oh, okay, I got some yellow here. So what was that on memory? This is cache. That's cached memory. Anyways, now as you go down into this, you can see the CPU, PID, user, primary, priority, nice level, virtual, all these things. It tells you everything. If I want to go ahead and look at a particular user, say I am Boz0040 and I'm checking on my box, I can, or on jobs that are running, I can go, you hit U, and then you can choose a user and it'll just show things from that user. If you hit uppercase H, it'll just show processes instead of threads. If I hit H, that shows the green. Those are threads. So I'm going to collapse that. K will show me our system threads, but this person doesn't have any system threads, obviously. I mean, they're not super user. So anyways, you can pick a specific processor or a process, and you can do an L. If you just hit L on it, it'll give you a LSOF on that. LSOF is LS open files. It tells me all the open files that particular process is using. So, you know, you can scroll down here and you can say it's on node 801. You know, here's the directory he's using is CWD, and that's MMFS1 scratch Boz0040. This is telling me, you know, he's using Intel OpenMPI. It'll give you all the libraries, everything that's in there. You do an strace on it, and, you know, it's basically just to see if it's alive, and if you can see what it's actually doing. If you hit F8, it'll give you a live scroll on that or not. Let's see. What else was I going to say on that? You can go ahead and choose any in particular thing and any particular process. You can hit space and tag processes. Be like, I want to kill these, because now you can go ahead and re-nice them or kill them. You can see down at the bottom, it's got, you know, F1 help, setup, search, all those sorts of things. F8 and 9 are nice or kill, so I could change the nice level, or I could say I don't want these processes running. I'm gonna get out of this before so I don't have anything going with this guy. Yeah, I'm not sure what else with that. HTOP is pretty useful for going ahead and finding wherever you want. It's better than, well, not better than, but it's interactive, so it'll help you get information quickly as to what your processes are running. Oh, I know what I was going to say on this. So you can click on any of the things up here to sort by memory, or like I can sort by how much memory is being used, how much CPU, you know, click another time and it goes down in the other direction. This is particularly the one that's more useful for us. A lot of times we'll look and we can see jobs, and we'll see that, you know, somebody's running a job, they've asked for a bunch of cores, but it's not multi-threaded. And so you'll see up here, there'll be like one core that's pegged out. And the person might think that they are using 28 cores or 48 cores, but they're actually only using one. And so their job is really not too efficient. So it's a good idea to go ahead and look at these sort of things, you know, every once in a while, and make sure that you're actually getting what you think you are. I don't think the CPU column shows up as a default. If you hit F2, you see down here, it says F1 help or F2 setup. Hit F2 and go to setup. You can choose, your meters. Your meters are the ones up at the top there, like your CPU bar and your memory bar and swap bar. The display options, it just tells you whether you can hit, you can hit like uppercase H or uppercase K to turn things on and off on the fly as well, or you can sit in there. You can change your color schemes if you want. But here's the most important one, you can change the columns. And so I don't think processor, you see active columns, I have processor, PID, user, priority. I don't think processor is a standard column. So you would go over there and just pick whatever column you want and then, just add it. And that's F5. And then you can go over to wherever that was that I just added, and you can just move it up and down, whatever you want. Anyways, let's remove F9. There you go. So I think that's about all I had.
Thank you, Tom. Awesome stuff. Yeah, again, that's just scraping the tip, but the main goal being, what Keenan and Tom mostly demonstrated, and what we see a lot, especially for new workloads or new software you're using, it's tough to really determine, is it performing the way I expect it to perform, or is it really using the allocation that I'm giving it? If I'm requesting, 48 cores, and I run some of these commands like Tom has run to show me, HTOP, how many cores is actually using? You can say, oh, okay, it's not really as optimal as I think it needs to be. Or maybe that's the way it's supposed to run, and I don't need to submit it with 48 cores, but I can submit 48 separate jobs. And you can optimize your experimentation just in terms of the computational components, as well as the automation capabilities for things that Keenan showed, which is like, show me some of the, give me a reporting type things, like give me a history of my jobs and show me what my average, whatever statistics you're looking at. So again, what we'll try to do, if this has been helpful to everybody, and for the first time in a while, it seems like it actually generated a little bit of discussion in the chat. So that's exciting to see. We'd love to interact with the research community and hear about some of the ways you do things. So if you have anything to offer, hey, reach out, or in a second, we'll open up the mics and you guys can ask questions or just, talk about what you do and some of the things you find helpful. I don't really think there's much left to do other than I've got maybe one more slide that says, thanks for attending. Let's see, get my PowerPoint back up. There we go.
Hey, brother, while you're doing that, just asking, we always struggle to come up with topics. We tend to do things that from our point of view. So if there's something that you would like to see, please let us know. We'd be happy to do that and go into depth on that.
Absolutely. Yeah, please do. Just real quick, documentation's Aubie/HPC docs, hpcadmin@auburn.edu. That's the best support email address. If you do have a support request, please send us all the information you can. And we prefer just text dumps in an email over screenshots. If you can do that, that's great. As well as, job IDs, errors, and if it's related, the pads or to your script or data. So yeah, with that, I guess we'll open the mic.